Welcome all to this webinar about Ansys Smart Apps and our new release of our app Weld Strength. Weld evaluation is a huge task when it comes to preparing a model, evaluating the results and the reporting. So it requires a lot of manual work, time-consuming work to do this. So our solution is the Weld Strength app. With this app, we can speed up the creation of weld contacts, so with automation to make it easy to update models. The new big enhancement is the build solid fillet welds, so creation of welds in the model without having geometry. Both continuous and intermittent welds, as I will demonstrate. To calculate and plot results for utilization, weld stresses, forces, and do the code check according to Eurocode 3 or other codes, user-defined codes. And it can also be used to estimate the minimum required weld section thickness, or to use Design Explorer to optimize solid weld parameters. So let's look at the first feature, the weld contacts automation. This feature allows you to create contacts for weld parts in the model and to avoid creating contacts between the ordinary parts. So I will show how this works on this model. So here I have a few solid weld parts, and by clicking this weld contacts button, it automatically now creates contacts between the weld part and the neighboring parts. So no contacts between the base and column, only contacts when it's a weld involved. You can also adjust here the tolerance, so maybe if I reduce the tolerance, I can also redo this, keeping the contacts folder, and it recreates the contacts using this new tolerance value. A next function, which is neighboring to this contact creation, is the contact match. So this is also a new feature in Ansys. You can do an imprint of the mesh in a contact pair. So it works in the same way. So if you have contacts in the model, by pressing this, it will create a weld contacts match and only keep match if there is a weld in the name. This only works for tetrameshed parts, so in this case I would have to switch method to use this. So in some cases this might be a good idea, but here I simply delete it. The next big new feature is the add fillet weld. Now this feature is very easy to use. You simply select a chain of edges where you want to place the weld, and you select reference face to orient the weld, and you specify the thickness, the weld type, and a material, and that's all. So let's demonstrate this in our models. So in this case I suppress this solid body, solid weld here from the model, and instead I now add a fillet weld using the tool. So to do this, I select the chain of edges. I also select a chain of reference faces, set the size, material, and when I'm done I get this green graphics showing the weld. So here I can see what happens if I add an indent of the weld. So we see it will leave a gap of 10 millimeter. Or if I switch to the intermittent weld, so adding here a weld fraction, and I can now easily change the number of welds, or the sizing or the spacing. So changing one parameter recalculates and update. So we see how the welds are placed. And we also automatically sees here what is the total section length and what is the total weld length, total weld mass, and also a proposed weld annotation. So now I go ahead and solve this model and have a look on the results. Okay, so here I don't see the weld yet, and since it's not a geometry based weld, I need to use the results file item in order to see the weld. So here is our solid fillet welds with that specified sizing, and here I can now very easily test a different weld size, update the analysis. And we see here the updated weld mesh. So the big benefit, since it's not geometry based, is we don't have to remesh the model, or there is no geometry update needed, so everything else in the model stays exactly the same. The weld is treated as a load object. As I show here in this next slide also, the add fillet weld can follow curved geometry. So in this case, I select two independent chain of edges. This is a big model, so it's a big throat thickness here. And pressing solve. In this case also have a few load steps that we'll come back to later, that when doing post-processing of welds, we can easily then evaluate maximum over time to have the worst case for every weld for all load steps in one single object. So now let's see this weld, and again I duplicate and select the results file item, and I see my weld. So as we see here, the weld perfectly follows the geometry, even if it's curved as we see here, and has always the correct throat thickness. So this type of geometry would be kind of hard to do in a CAD program. And also, if I like, I can change here and use intermittent weld, or changing the sizing very easily. Also, the main properties of this weld we see here. I can select the number of elements, so I can select from 2 to 4 elements over the throat thickness. And I can also, if I like, change the aspect ratio of the element. By default, the aspect ratio is 2. But I can easily, if I open the preference file, change to another aspect ratio. There's also a check here for minimum and maximum angles. So Eurocode 3, for instance, have 60 to 120 degrees angle as valid angles. So if the angle is sharper or flatter, it will not create a weld there. So as I showed here in this example, how we then can use intermittent welds very easily, and also how it managed to deal with open and closed chain of edges. Also, the big possibility with this integrated weld feature is how we can then easily assign parameters and do design point studies. So by clicking in, for instance, the throat thickness, number of welds, or weld length, or some combination of parameters, we can run the simulation and get outputs in terms of the weld utilization and the total weld length and weld mass and so on to calculate the cost or production time for this structure. Once we're done with our weld creation, we can export the weld both as a solid geometry or as a line file. So in this first case here, I'm using the weld mesh into an external model and link it down to geometry. So here I'm showing this weld objects in the design modeler, and here I can then export this to any other CAD formats. So after the solution, the weld mesh is available, but I can also, if I like here, export the weld mesh up front. So the export of the fillet weld here is the unmorphed original weld geometry. The other option is that I can export the weld seam lines. So this corresponds to these green segments. So again, if we have a look on the weld object at the bottom, we can select here whether we want a space claim or design modeler type file. So this is a text file that you can import directly into either space claim or design modeler and use for your own purpose. So for drawing preparation or other tasks. So for post-processing a weld, according to a specific code, we need to assign what kind of weld it is, what code, what material, steel grade, safety factor, and so on, and what kind of results we want to look at, if it's the utilization, if it's the section forces, or some component stress, and so on. So let's go on and do this here. So in solution, I insert this fillet weld strength. So first here I demonstrate this on an existing weld. So I need to select the weld section edges and the reference face. I specify what kind of weld, if it's here a single-sided, double-sided, intermittent. So this is single-sided, 3mm, Eurocode, let's change to higher steel grade, so it sets the material values. I can go on and edit these myself. And I want also to add a result for this fillet weld I've created here. So instead of using manually select, I pick this from a list and it automatically fills in the selection. So again, I set another value here. So then I only need to evaluate. So the weld utilization here is, as we see here, below 1, so this should be then okay. And again, here's looking on these results here, looks okay as well. So again, if I like, I can test what if I reduce the size of the weld, so simply updating the analysis, updating these results. So here we see now we're falling above 1, so this was not accepted then. Of course, we can then test to go for a higher strength material, and we're right on target. So now I showed this app for a solid weld, solid model with both solid welds and also in the case with no welds and simply a multi-body part. But the app also works for shell models, so selecting a reference edge, a shared edge, and a reference face for these type of shell models also works. So we see both for fillet welds and for butt welds. So it works both for planar and cylindrical faces. So the recommendation is to use thin solids with solid shell. That is a very efficient way to model. And then you can also use this add weld feature. So the add weld feature does not work on shell models, only on solid models. Also recommending to use contacts compared to multi-body parts. In addition to this result plots, we also see get a result listing. So looking in our solver files directory, we see here a text file with a listing of what result object, what time, what weld type, what code, and we also then see here the edge IDs and the group. So this is one group of edges. So open the other result object, weld strength, first object here. We see two groups and edges grouped for each group individually. So here we see all the available results for all these sections. Now we can also look at the nodal results. So again, in the results file, we also see here this Excel file or a CSV file. So with this, we can see the different results items, but we here also have the nodal results. And we can sort these results. So I sort them by the section position. So this means that I can now, for instance, plot the utilization or this the equivalent stress along this weld. Or I can also, as we see here, I have, if I move this around, this is the utilization. I can also use this to create new results or doing load case combination and plot it back to Mechanical using the CSV plot app. So as we see here, we can plot not just utilization, but we can select here to plot the path location. So we see here, starting from 0, going up to 380, the local position coordinate y. So that's why it's very easy to manipulate results doing these path plots in Excel or plotting results back. So here I've shown this, how I've taken a new result using CSV plot to plot the results back on the geometry. Included in the app is a Eurocode 3 method and also a DNV fatigue method. All these methods are component stress based, so we are looking at, if I open up the help documentation here, so going to weld codes, Eurocode 3 looks at the stresses and shear stress and normal stress in the throat section, and use this to calculate an equivalent stress. And we also have the simplified Eurocode 3, where you do a simple equivalent stress check. And same then for the DNV fatigue, which is also using the component methods to derive an equivalent stress that you can compare with a limit value. So you can actually also define your own weld code. So in this preference file, we can add our own section if we, for instance, want to use just shear forces in the weld to do an evaluation and not do these combined results. So that concludes this big demonstration. So the speed up building and post-processing using these tools is a factor of 10 at least compared to doing this in creating geometry and all these manual steps. So the return on investment for buying this app is, I mean, one project and then you're earning money. So also not just speed up, but you also get the easy to view result plot and listings. Easy to do this external post-processing of these results in Mechanical and plot it back in Mechanical. The possibility to do optimization, updating the model. And we can also use it together with our other Weld app, the Weld Fatigue app. So using the geometry for creation of effective notch models and use submodeling, for instance. And also how we can export the weld geometry and weld lines for other purposes such as drawing preparation.